Hello, everyone. Thanks for joining the webinar today. I am Kaushal Trivedi, Associate Director, Business Development for Teledyne ISCO. This is a joint webinar by Teledyne ISCO and SENTRY, and the title of the webinar is Effectively Manage Your Facility While Saving Time and Money. So the agenda today will be that we will introduce both the companies, Teledyne ISCO and SENTRY. We'll try to state what is the problem that we are trying to solve, and then we will talk about the SENTRY Toxicity Center first and ISCO Automatic Sampler at the later part, and how these two products are interfaced to get real-time information at the same time toxicity, representative samples for the toxicity. And what are the benefits that you will get from this? So let me give some introduction here first. So in this webinar, what we are trying to explain how toxicity event can be captured in a real time, and how it can help managing the facility efficiently. As I mentioned, it is a joint webinar between Teledyne ISCO and SENTRY. So we will start our presentation with SENTRY toxicity sensor and how it works and how it captures the toxicity event in a real time. We will then present how Teledyne ISCO automatic sampler can help taking representative sample to the event detected by SENTRY sensor. It will be very interesting webinar, I will say that. But I also would like to mention that this will be two-part webinar series. Today, in part one, we will discuss event-based sampling. Event is basically toxicity event sensed by SENTRY sensor, and then how the Teledyne ISCO sampler can be used to capture that event or capture the samples during that event. In part two, part two will be equally or more interesting, where we will present how the real-time pollutant signal can be used to measure facility loading. The second that webinar is expected to be in next 1 or 2 months. You will get the notification, so please stay tuned. It will be very, very interesting webinar because it does all the load calculations and how the load calculation can be used and what are the benefits of that. Please note that both Teledyne ISCO and SENTRY are independent entities and provide their solution independently. This is more of an educational presentation. It is a technical presentation without going into too much detail, such as programming of each products and everything. We'll not dive into all the stuff, but we will present a technical solution and what are the benefits. So let's start with a problem statement. What is the problem? What we are trying to solve here is to avoid harm to the treatment facility and efficiently manage all treatment processes. And how can advanced information be obtained on the toxicity pollutant in influent and capture representative samples for detailed analysis and corrective action? So basically what happened that the toxicity events, when it happen or the pollutant comes to the facility, it can create more harm to the facility. But if you have an advanced information, you can take some corrective actions and you can avoid harm to the treatment facility. So how we will do that, that's we will discuss in today's presentation. So now I would like to invite Mr. Jon Grant from SENTRY to present SENTRY solution and how it captures the toxicity event in a real time. John?
All right, thank you, Kaushal. Really excited to be presenting with you and the team today. So yeah, I'm John. I lead SENTRY's commercial efforts. And so the question might be, what is SENTRY? So first and foremost, we care about the environment and making better decisions through understanding variable influent and helping that become a predictable outcome at the headworks of a wastewater treatment plant. And our typical client, is a person like Carl. So Carl's the plant superintendent at a site, Frankfort, Kentucky, where they take in 14 industrial dischargers, including one very large distillery. And they've had some issues in the past in terms of what's coming into the plant. So we support them on that real-time monitoring at any time. And so really the three things that we help a conventional plant out with are, how do they improve processes? How can they, improve treatment and reduce greenhouse gas emissions? And the other big one that's coming up even more often is, how do I sample when an event happens? And that's a challenge because there are times where an industrial discharge may not affect flow, but the quality of an organic overload or a toxic shock will impact treatment heavily. And so you'll see how that plays into the further discussions. So just a bit of background. Our technology was developed by Pat Kiley when he was contracted to deploy what we believe was the world's first packaged, entirely powered by solar power wastewater treatment plant off in the desert, where there was not reliable ways to get operators out there to clean sensors often. So he developed this technology based on his postdoc work to monitor treatment performance, and did that about a little over 10 years ago. And we started selling the probes to the market about 6 years ago. And as you can see, we're starting to grow around the world. We've got about 400 systems deployed in our history, and we detect about 27 events daily. And our goal is, again, to save money and protect watersheds. So why is our sensor different than every other sensor? Well, most sensors are either physical or chemical based, and it's sometimes difficult to shine a light through wastewater at the headworks location of a plant. And otherwise you're cleaning probes and calibrating them quite often. What this sensor does, and this type of technology does, it's actually based on the metabolism of the microbes. So the biofilm that's in your plant that powers the biological processes, that consumes carbon. That's really all it does for a living. And then it has a metabolic response. And so we convert that response into a digital signal in real time in the form of 1 minute readings as a consumable BOD or RBCOD. And there's no moving parts, no calibration, and really it's a reliable stream of data on the question of, can my plant handle the incoming load? And so these are two probes that were installed 18 months apart at a primary clarifier in United Utilities Skelmersdale location, just south of Manchester. They were scientifically duct taped together. This is not a recommended install, by the way, but it was great for those purposes. And so these probes were installed in 2019 and 2020, and they are still providing reliable readings every minute that move in lockstep. The last time that they were touched that we know of was about 2 years ago when they were pulled out for this photo. So, they're doing our goal of just providing that reliable data. As you can see, we don't want them clean. We want them to look like that. And really, it's just so that biofilm can consume carbon. That's all it does. When you look at it from a larger perspective, these are the base principles. Again, biofilm consumes carbon. That creates the electrical charge, which we convert into a digital signal, and it allows it to look and feel. Ultimately, if you put it in a human context, like a Fitbit or Apple Watch, so a heart rate monitor for your plant's ability to treat that incoming wastewater. And that becomes powerful because most of our deployments are at the influent monitoring. About 70% start with or include influent monitoring, and that's a great place to understand what's coming into the plant from an overall quality perspective, and can I take action early enough, in terms of blowers, changing blower speeds, dosing chemicals, and various other treatment process techniques at disposal, divert to EQ tanks, things like that. And typically we like to install right next to a sampling point, and so we'll get into that in a bit. But what it looks and feels like from the perspective of our sensors. Great day, just domestic waste. From a quality perspective, we'll see diurnal trends. Activity goes down late at night, ramps right back up in the morning, and stays strong throughout the day. The problem is when you get something like a toxic shock that you can see on this lower graph a couple of times, or an organic overload, could be a microbrewery, distillery, food producer. It starts sending everything out of whack without a noticeable flow trend associated with it for the most part. If there's a dilution event, you will see heavier flows. And that becomes an issue for understanding processes and issues beforehand. So taking a sample to identify the exact contaminants is a natural fit for us to work with. When we look at the three types of signals that you'll see at the headworks, you'll see high organic loadings, that's spiking up. That means there's a lot of food available for the biomass, and it's really just there to consume that carbon. When we look at industrial discharges, you'll see short spikes down. They can last for a long time, but typically they happen within 15 minutes, 30 minutes, an hour. And so catching them in real time is key for treatment processes, but then identifying what the exact contaminants are so that you can trace back to who likely was the discharger is key. We also pick up dilution events. That just means there's less food available for the biomass. And here are three of our sample case studies. Sewer Authority Mid-Coastside in California. They've been able to reduce 80% of their manual sampling, not their regulatory sampling, but their process-driven sampling, and that's saved them an estimated of $50,000 a year because they've been using SENTRY to trigger event-paced samples on their own, and that allows them to really just capture issues only when they're happening, and not just the regular 9 o'clock, because you could miss everything. And typically, we know that almost every city universally or town that has industrial discharges gets discharges at 4 to 6 p.m. on a Friday, because that's when it gets sent down the line. This will allow you to identify that and sample accordingly. Similarly, Peterborough has used us to identify when various different industrial dischargers have sent stuff down, and typically when they would see changes in color or smell or things like that, they'll start ramping up blowers, get ready to dose chemicals. We've been able to help them avert it when it's not actually going to cause them an issue, and so they've saved money, or ramp up quicker when we start to see organic loads or toxic shocks. And then Frankfort, Kentucky, as I mentioned before, with Carl, when they get high organic loads, they will divert to their EQ tank and dose back in with slight changes to their oxidation ditch to really optimize that increased load. And so that gets into how have we started working with samplers, ISCO, in terms of event-based sampling. This is at Micron in Singapore. So they're interesting because they have 3 different samplers right next to each other. One is the regulatory one. One is their own manufacturer-owned one to check the regulatory one. And then the third was ours to help identify process-based issues. So when they would discharge, if there was an event and it was sampled, they could then trace that back to what was exactly happening within their processes in the lead up to that, and try to either mitigate that or change them in different ways. So this was really the first time that we were connected to an ISCO sampler and got the privilege of taking that photo. And that really led to a lot of our discussions a couple of years ago. And again, like I said, the way we've done this with groups is, triggering a real-time alert threshold. We've seen up to 80% sampling reduction, and really the goal is if you're looking to catch things, there's a very narrow window if you're just doing random manual samplings or every day at the same time, versus doing it event-based, and that allows for a higher chance of catching things that are causing an issue at the plant, and then being able to clearly identify that. So from my 30,000 feet, essentially a SENTRY signal will, the sensor moves along. Most days are usually pretty fine at most plants, and then you get an organic overload or a toxic shock, and based on that, it will trigger an auto sample, or a sample to be taken, and that allows for further analysis and a clear understanding of exactly what was in that wastewater. So effectively, you can take action based on the overall signal and then understand and trace back with the lab results. And that allows us to know early so you can act. And thank you very much. I'll pass it back over to Kaushal.
Thank you, John. Excellent presentation. I will say that SENTRY provide a great product to detect and real-time organic overloading or toxic shock, kind of an information in a real-time basis, which is an excellent thing. Now let's discuss how to capture the representative samples during such event. And before I diving into it, let me introduce our company for those who don't know. Teledyne ISCO was established in 1958. And in 1971, we invented the first automatic wastewater samplers globally. That time there was no automatic samplers, we were the first one. And since then, and actually now, we are world leader in samplers with expertise in wastewater-based surveillance, many areas, including PFAS detection, wastewater-based surveillance, and now we are going to talk about even toxicity events capturing. So with this company introductions, I want to invite Steve McManus, our product support specialist, to explain samplers and what features can be used to get representative samples during this event. Steve?
Thanks, Kaushal. What I want to talk about here first is just introduce myself. My name is Steve McManus. I'm the Senior Product Support Specialist for Teledyne ISCO. I have worked at ISCO for 40 years now. And in that position I do a variety of interaction with customers on a wide variety of flow metering and sampling projects. And this is a very interesting and unique new approach, if you will, to utilizing the equipment for the benefits of our customers. I'd also like to thank everyone for joining us here today. It's a pleasure to speak here in front of you. So for sampling, there are two basic methods and approaches to taking your samples. There's grab sampling, which involves an individual or individuals traveling to the site and literally manually collecting that sample by having a pole and a bottle that they dip into the flow to collect a sample that they then draw out and put into a container to be brought to the lab. An automatic sampler can also be used for grab sampling by just walking out to the site and dropping the line into the flow and having it collect the sample. And again, This is an approach that is when the individual is there. So for the application that we're talking about here, the chances of the coincidence of an event happening at the very time that someone is out on site collecting that sample is very unlikely, and therefore this would not be an appropriate or very likely method of sampling to achieve the goals of identifying when there is a slug, an event beginning to occur. There are also automatic samplers that can be positioned to sample at various locations and can be programmed to collect a sample based upon flow-weighted sampling intervals, where we collect a sample every X number of gallons, or time, where we do so on a number of minutes. We can also have a variety of bottle configurations that range from a single composite bottle, where we have a sample that is representative of the accumulation of all samples collected over that interval of time, typically a day. Or we can have sequential sampling where multiple bottles are utilized, and each bottle can represent a specific interval of time over that sampling interval, such as if you have a 24-bottle sampler, you can have it switch bottles every hour, and then every bottle 1 through 24 represents an individual hour over that 24-hour day. So for sampling routines, we have a variety of options to configure the sampler for collecting those samples. First of all, there's time-based, where we can tell the sampler to collect that sample every 15 minutes, every hour, every 30, and throughout that interval of time where we have the sampler program configured to operate over, it will collect that sample every 15 minutes at that regular interval over that period of time. I also indicated we can do flow pace samples, where if the flow meter is involved and connected to the sampler, it can provide information to that sampler, and every X number of gallons can be configured by the user to have a sample collected. So if every 5,000 gallons of flow that pass that location, we want to collect a sample. For the application that we're really referring to here, and this really feeds off of what Jon was talking about, we can do event pace sampling. So we're not doing a regularly paced flow or time. We're waiting for something to happen to trigger that sample into action. And in this case, that event will be a given parameter for this toxicity going above or below the range that we consider to be normal. And so we are able to collect a sample when the event is underway. In a number of our model of samplers, we can do a combination of different pacing intervals, where we can collect samples in separate bottles that maybe one set are based upon time or flow, and the second set of bottles within that sampler are just in reserve and awaiting events to happen that may or may not happen. And it's those two particular modes of sampling that are really advantageous for the application needs we're discussing today. As was mentioned by Jon, these toxicity events can be very short-lived and spiky in nature. And if you have a toxicity event that only lasts 10 minutes and you're collecting samples every 15 minutes, the chances are possible that you may miss the entire event altogether, because you may collect a sample before the event begins to occur. The event happens, hits its peak, begins to fall, and is no longer in play when the next sample is collected, and therefore we have no visibility that we had such an event in our sample analysis. So the benefits of applying a ISCO sampler and utilizing these configuration modes, that we can protect the plant by catching the problem at the time it begins. And again, we can do manual time or flow-paced sampling, can miss those events. So the event-paced sampling allows us to guarantee that we are collecting a sample in the midst of the event that we're trying to track, trace, and determine what actions are required for the treatment plant to protect the activity in the treatment plant. So we can take that corrective action as soon as possible, and we do not have to wait for laboratory results to be returned and find out that a week ago or a day ago or even 2 hours ago we had an event. It's too late by that time. This allows us to reduce the risk because we get the alert as soon as the slug arrives at the influent of the treatment plant. The auto sampler can begin to catch that sampling event at that very moment. Alarms can be provided to inform people of what action may need to be taken based upon the state of that event. When we're in extended programming, we have a variety of pacing options and other programming options that we can program into the sampler. In addition to doing uniform time, where we collect a sample every 15 minutes, we can program a non-uniform time pacing where we can have various intervals between samples that we can program into the unit. We can tell the unit we want to take 96 samples over a 24-hour day at a random amount of intervals between samples, so the sampler itself will decide when it wants to collect those samples, but it will divvy it up so that at the end of the day or whatever interval that you've decided you want to sample over, you collect the number of samples that you desire. We can switch bottles based upon time, or we can switch bottle sets based upon time, because we can have 2 bottles per sample. So every sample that's collected, there's a sample placed in multiple bottles. Again, user definable. We can do flow proportional sampling where, as indicated, if we have a flow meter involved that's monitoring the flow and able to provide volume-based detail to the sampler, a pulse every 1,000 gallons or whatever the case may be, we can program the sampler to collect a sample at a specific amount of volume that passes our monitored location. We have a variety of programmable sampler enable conditions that we can utilize to say, don't sample, wait for this to happen. Whatever this is again, is user definable. And in this particular discussion of the day, this would be that our toxicity has gone above or below our acceptable normal range of value. We can program pause and resumes into the sampler, so we can tell the sampler to pick up and be ready to collect samples or actively run samples if we have something like a time-paced program in, and then at some point in time stop and pause. For example, if we only want to sample from 8 to 5 every day, we can have it set to pause at 5 o'clock in the afternoon and resume automatically at 8 o'clock the next morning. These next 3 bolded are the primary programming options that we would utilize for this application need. Event pacing, where again, we have a device, in this case the SENTRY, being able to provide that toxicity detail, and there are decisions being made that if a value goes above or below the acceptable range, we want to collect a sample. Again, we can do multiple bottle compositing to where we can have bottles 1 and 2, bottles 3 and 4, each equally sampling at each sample interval. We can do 2-part programming, which is effectively allowing us to have 2 samplers in one, where we can partition off a segment of the bottles we have in the sample for something like our regular time-based programming that we may be utilizing for other purposes, other regulatory needs that we're analyzing. And we can have that second set of bottles partitioned off for event pacing, so that in the situation where we have a value go out of range, we can collect samples when they do. We have the ability to automatically allow the sampler to determine the lift involved, or put that in ourselves. We can program in line rinses so that before the sample is delivered to the bottle, it draws the sample up to the pump, flushes it back out, and we can do so multiple times so that any residual material that may be resident within the inside lining of the tube is rinsed away, so that the sample that's being delivered to the bottle is most representative of the source it's drawn from. We can also program retries. So in the event that something were to happen, some material gets drawn into the line that momentarily restricts or blocks the intake of water, it'll do a purge and then retry to collect that sample a second time so we don't miss any sample events. And again, those three particular bullet points there are the primary programming options that would be utilized for this application need. We also have the option of being able to, again, here with the two-part programming, if we have, for example, a 2-bottle sampler, we can have the first bottle programmed to do our normal daily time or flow pace sampling for whatever application or regulatory need that sample provides, but then have the second bottle set and only sample in the event that we have a toxicity value that goes outside of the range that we have defined as acceptable or normal. And therefore we have one sampler performing two options. So again, it's effectively two samplers in one. And we can do the same thing with different bottle configurations, such as a 24 bottle. We can have the first 12 bottles defined for, again, our normal time or flow pace sampling program, and then have the second set of 12 bottles, bottles 13 through 24, partitioned off and only become active for sampling in the event that we have a condition that goes outside of our defined normal parameters. And with that, I'd like to turn it back over to Kaushal.
I would like to explain these features in a real-time application, applications where it was used. So this is the pictures what John had was showing earlier. This is from the site in Singapore, where you can see on the left side there are two samplers installed for regulatory requirements. So regulatory requirement was time-based or flow-based. Here in this case it was a time-based. So they have used those sampler just for regulatory requirement, and a periodic sampling was done. And they use, you can see the label on the right side, the first left picture, right side sample, okay, that says toxicity event. So that was used only for the toxicity event. Whenever the event take place, they take samples out of it. And when I open that third sample box, entire box, this is how it looks like. That is how they have interface. That's the right side picture. So this is basically used for for two separate sets of sampler for regulatory and event based. But as Steve explained, if we use two-part programming, you can use one sampler for both the purpose. You can use extended programming that can help you event-based sampling also, and without compromising regulatory requirement of time or flow pace. It's all depend on what is your regulatory requirement, but you can continue doing that. Or if you don't have time or flow base, you can continue using only event-based sampling. But just would like to explain that this is, our samplers are capable of doing or meeting both requirements. And the benefits what you are getting with this is that, measures what matters. collect and test the samples based on flag of organic overloading or wastewater toxicity. So what happens? So because of that, you get a signal from SENTRY sensor, and you are capturing the samples. So then you can quickly identify the source. As John was explaining, it can be overloading or toxic shock. You can figure it out what is happening. We are not an expert of the analysis, but I believe that each toxicity event can leave a signature, and you can identify the source, whether it's a distillery or dairy industries or plating industries, from analysis of that sample. So if you have captured the representative sample during that event, you should be able to quickly identify the source, and you can take a corrective actions for that. So that's very helpful, using this kind of an event based or two-part programming. It can help you identifying the source. At the same time, it also can do the cost saving, because many times it is involved a third party. Your regulatory sampling you can do in your labs, local labs, and available on a facility. You can continue doing and record that reading and report that reading to the EPA or DEQs, wherever it is. But when it is event-based sampling, sometimes because it is a third party involved, they may ask for the third party lab to use third party lab. Those sampling are expensive at third party lab, but you don't have to send every samples to third party lab. The cost saving, this event based sampling or two-part programming sampling can help you, that you are capturing samples only during that event, and you have to send only those samples to the third party lab and pay for it. So let's say if event has not taken for 30 days or 45 days, and it has happened on 46 days, you are sending samples of only 46 day to the lab, and you save tremendous cost. That is what the cost saving comes into picture, overall, what John was talking about. So these are the benefits of using SENTRY sensors along with Teledyne ISCO sampler. So that's conclude our presentation. So if you have any questions, we are opening now for any questions.
Well, thank you, John, Kaushal, and Steve, for sharing your expertise. And yes, Kaushal is correct. You will see a questions box that you can submit any questions to our presenters, and they would be happy to answer. So please submit your questions. Thank you. Well, hello, everybody, and we would like to thank you all for joining us today. And we do have a couple of questions here. I will start on a question concerning being addressed to SENTRY, and that is, how does SENTRY team calculate the maximum minimum CBOD threshold for toxicity events? John, do you have the answer to that?
I'll take that, Shan.
Oh, hello.
Right. For the measurements, what we basically do is we install the sensors. We let the sensors acclimatize, and we develop a baseline. And this baseline keeps varying for every wastewater. So the consumable carbon that is present in wastewater keeps changing. So what we do is we set up these alarm bands based on the statistical measurements and the baseline developed on each site. Thanks, sir.
Thank you. Steve McManus is also with us, and we do have a sampling question for you, Steve. Can you also do it volume-based event sampling? Is that possible?
For all intensive purposes, flow-based sampling truly is volume-based, because you're telling the sampler, configuring the sampler in a manner that you will collect a sample every fixed amount of volume that is passed through the monitoring location. So you can have it set up, and I'm just going to pull some numbers out of the air here. If you want to collect a sample every 1,000 gallons based upon your mathematical, approach to determining how often or how frequently one wants to collect a sample at a site, if that turns out to be 1,000 gallons, the flow meter is accumulating a volume as it's monitoring the flow, and when it reaches the 1,000-gallon threshold, it can send a pulse, or if it's a 4 to 20 signal, we can analyze that signal within the sampler and convert that to a pulse, a volume, and continue to collect that sample at that 1,000-gallon volume. We can also, with some of the extended programming mode options, have the ability to define the amount of sample that's delivered to the bottle based upon the amount of flow that has been monitored over that sampling interval. So the answer to that question in a roundabout way is absolutely yes, we can do volume-based sampling.
Okay, thank you, Steve. And here is another SENTRY question. Can I integrate a SENTRY sensor to existing ISCO samplers? Is that possible?
I'll say the short answer is yes, and then maybe Kaushal, if you want to take this this one further.
Sure. So yes, you can connect a SENTRY sensor or SENTRY system to any of our sampler, and depending on the model of our samplers, we make a different type of model: portable, portable refrigerated, permanent, and in permanent we have a couple models. In portable we have a couple models. So depending on the model, we can provide an interface unit in between. For an example, if you want to use a flow and SENTRY signal together, you can use a signature flow meter, bring both the data inside signature flow meter, and then you can trigger sampler, enable sampler from signature. That's one way of doing. Other way of doing is you can use SENTRY system. They have 4 to 20 output that can go to PLC or SCADA system, and from that you can trigger the samples. You can send in event pacing to samplers, and you can trigger the samples. So depending on the samplers you have, the configuration can be different. But as John said, short answer is yes. You can pace ISCO sampler, any of the ISCO sampler, using SENTRY system.
And I would add to that, all of our sampler models are able to accept very light signal intake, whether it be a contact closure, a voltage pulse, 4 to 20 milliamp signal with a converter. So basically all sampler models that ISCO has manufactured for as long as I've been here, the last 40 years, have very similar signal input options. So the absolute answer to that is yes, we would be able to utilize this interface with any ISCO sampler model.
Okay, thank you. And let's see, we have some other questions. Does influent usage offer enough time to react to shock loads? Have you done deployment upstream within the collection systems?
I'll take this one, I guess. Yeah, so for SENTRY in our conventional use, about 70% are in headworks, and so typically, depending on the configuration of the plant, it is early enough. We're installed at headworks primarily, and from there, we have been integrated to trigger samples or work on things like controlling blowers. That's a preview for the next webinar that Kaushal will talk about later. And then in the collection systems, that sample, that site that we showed in Micron, that was at a pre-treatment site. So that would be the most common usage. of this type of technology combined.
Well, thank you, John. Here's another SENTRY question. Where is the SENTRY data stored? Does the sensor have internal logging, or is the data output to a SCADA or PLC?
Yes to all of those. So a standard SENTRY system comes preloaded with a SIM card, connects to our cloud. It's Azure or AWS, depending on the location. And from that, when we do integrate with an auto sampler, we've typically we've done it historically either through SCADA or directly into ISCO through their signature communications protocols. Did that answer that?
It appears so. I don't have any further clarifications coming in on that, so I think you answered well. Does anybody else have any other questions? We certainly will leave it open for you to enter those a little bit. Kaushal also wanted to share that we are going to be doing a part 2 with SENTRY. It'll probably be a couple months down the road before we'll be ready to present, but we're really excited about this presentation, as it really will dive deeper into our businesses. Well, I do not see any other questions coming in. I want to thank you all again for joining us, and thank you to our presenters who have done an excellent job of answering these questions. This webinar has been recorded, and we will be sharing the video along with a copy of the PDF version of the slides for you. If you have further questions, we have provided contact details on the screen. If you haven't had a chance to write those contacts down, feel free to email us through GoToWebinar, and we'd be happy to pass those questions on. So I would like to wish you all a beautiful day, and we hope you will join us next time. Thank you.